Now, so a lot of things I haven't done, but we're going to slowly go through, like the importance of what a definition is. They have to learn that. They have to learn that. You know how you can convince them that they should learn it? Can they hope to live legally in this country without knowing the law or the Constitution? They have to observe certain things, don't they? Can they just punch someone in the nose? They can if they don't mind being, beaten up or something. There are certain things you're not supposed to do. Because what? It's written in one of the codes of law that thou shalt not punch someone in the nose. Right? In fact, a child growing up have to learn certain things can be done, certain things cannot be done. At this stage, what they cannot do is to start fooling around with this symbol, what the high bottom are more than just whole numbers. That they cannot do. That's the important part of learning mathematics because it's part of their maturity, emotional maturity. There are things you cannot do, period. There's no argument about this, right? The importance of definition is sort of like the Constitution. No, you don't change it. You don't go around changing the Constitution any way you wish. It's there, that's it. Yeah?
I talk about it as the rules of the game, that if you're going to play Monopoly,
Yes.
you have to follow the rules of Monopoly. You're not going to apply the rules of sorry to the game of Monopoly.
Do you think they all know how to play Monopoly? That's a problem.
That's a problem.
So no, that's why but you're right. With children who will play games, that's the best analogy. The rule of the game. Oh yeah. No, I normally say this. Or sports. You play basketball, right? You like to hug the ball and walk all the way from one end of the court to the other? It's natural, isn't it? Natural. But you just don't do it because you've been caught for childing. Right? So that's, you use one of our analogies to make them see. They have to learn to respect definitions. I mean, so this is one of the, no end of such things, but one of the greatest sins of current textbooks is, have you ever seen a definition that's important in your textbooks? You have ever used? Have you ever seen a definition that's really important? Have you?
Diameter. Sometimes they give the definition of diameter.
No, I grant you that. Maybe they, even that I doubt a little bit because have you ever seen a diameter used seriously in a logical argument so that very definition?
No.
Yeah, that's right. But you may be right though. I was slightly exaggerating. But the total neglect of definitions in current textbooks makes mathematics completely unlearnable. For the reason we went through, namely, you say a fraction is something like this. Now you're a young kid, right? You just say, you latch onto it. That's great. That's a piece of pie. That's not. Right? 4 minutes later, you say, oh no. It's something in the square. How do you feel as a kid? You're changing it again at your whim. I mean, how is someone going to learn that if you keep changing the rules of the game? They have nowhere to learn, nowhere to turn. When you tell them, you and I both are bound by this law, namely fraction, put on a number line, let's both do it. If nothing else makes them feel better, that you are as tied down as they are. You're on equal footing. Okay. Now, so all that propaganda. To say, we still why this is important, right? And how you should look at a fraction, right? So let's put it to the test. So let's talk about addition of factors. Now, the thing about addition we talked about, right? Addition should be combining things or counting things. Should not be this least common multiple, this LCD, and then the funny business, none of that. So we're going to define fractions. Let's say 3 over 5. No, let's say 3 over, let's do something. Sorry. 3 over 4 plus 1 over 6. Now, In textbooks, what do you think they do? They just say, I tell you how to do it. Right? Get the LCD, so. I want you to form this habit, in fact, no, better yet, form this instinct. That you never approach something like this without first asking, what are you doing? You have this? What are you doing? What does it mean? 3 4 plus 1 6. What does it mean? No textbook ever does this. Am I wrong? When you can, sometimes I make completely sweeping statements, and you're all invited to contradict me. I have not seen a textbook that says, what does it mean? And then you say, I know what it means, then I want to compute what the value is. They're two different things. See? First of all, I have to know what it means, what I'm doing. What am I doing? What are you trying to do? Once you know what you're trying to do, then you say, now precisely, what is the value of this thing? They're completely different. So I'll illustrate with this, right? Right now, I want to tell you what is meant by adding two fractions. Okay, now we'll come back to fractions. 3 4, more or less, that's 3 4, right? One sixth, well, of course, don't mind me, so more or less is, yeah, there's 1/6. Okay? So 2 numbers. I have to say, what do you mean by adding these 2 points on the number line? Well, I'll tell you what. I begin with this segment. Now, after a while, you begin to see that instead of saying 3 4 is this point, it's the same as saying that segment from between 0 and this point. Meaning, you mentally identify the length of this whole segment with the endpoint itself. That makes sense? If I know the endpoint, I know this segment. If I know this segment, I know the endpoint, so the two are completely interchangeable. So after a while, when I say 3 4, yes, that's the point on the number line. But I also can, if I want to, think of that as this whole segment. Okay. So then you talk about the length of this segment is 3 4. That's. So then, if that's the case, I should 1/6. It also determines the segment, right? I'm going to tell you, when I say this plus this, I mean the point obtained in the following way. Stay with this segment, 0 to 3 4. And then move the segment from 0 to 1/6. Move it here. Slide it down.
No, to the 3 4.
Yeah, oh, sorry.
Yeah.
Same length. Okay. That is what we mean by the sum. That's the meaning of the sum. Now you notice I'm combining things. Adding is exactly the same as combining, counting for whole number. Right? If you don't believe that, let's look at 2 plus 3, right? 2 plus 3. Now 2 is a fraction, 3 is a fraction. In this sense, 2 plus 3 is 1. So we call it this method, 2 plus 3 should be equal to 1. This is 2. Then move the 3, slide down here. That's the 3. Move it. I cannot draw that. Okay, rather not draw this. Then we say, well, that's what we mean by 2 plus 3. But sure enough, that's, of course, that's exactly what it is. For whole numbers, that's exactly what we mean by adding. So, the important thing that you want to explain to children is that you haven't changed a thing about addition. It's exactly the same as before. What they have learned will be useful. That's what you want to say. The continuity is very important. The word coherence you use often now in describing the canonical scale. The word coherence is entirely mathematical. This is one manifestation of coherence. Meaning what? What you learn about whole numbers is completely consistent with what you learn about fractions. No change. Notice, do you think there's a change? Do you think the meaning of addition has changed until then? It's exactly the same. So coherence means everything is all of a piece. That's exactly what it says. Okay, so now you understand, so you're just putting things together. With that understood, you see, if I give you, I let you I want 2/3 plus 5/3. You now have to add. Of course, right? Let's go through the motions. So on, right? So we say 2/3, that's 2/3, right? That's 2/3. Right? And this is 5/3. So what we say we do? We say that take this, slide it down until it's in. Meaning that, right? Making sure everybody follows me, right? Now, I'm talking about the importance of definition. I'm saying, once you say this is how you want to add fractions, don't ever change because that's what you said. Don't ever take back what you said. You want to take it back, change it officially. Say, well, sorry, I made a mistake. But what you said, you have to abide by it. What you just said was adding fraction is combining segments. Oh, by the way, if you look at the notes, I think the notes have this fancy terminology, concatenation. Right? Adding is the total length of the concatenation of the two segments, meaning string them together end to end. That's what I learned from computer people. You string files together, remember?
Yeah, it works out.
It's concatenate. I thought that's a great word. That's exactly what it is. So concatenation, let's use that one, right? So how do you concatenate? Well, what are you concatenating? You will have two pieces of the thirds. You tap onto another what? 5 pieces of the thirds. How many? What do you think is the total thing?
7.
It's 2 plus 5 is 7. Right? Now, does it remind you of something? For adding these two fractions, does it remind you of something? This whole number addition, right? 2 plus 5. Other than the fact that 2 plus 5 is 2 of the ones plus 5 of the ones. But now, 2/3 plus 5/3 is 2 of the thirds plus 5 of the thirds. This is concatenation. Just as counting, same as before.